konservasi manajemen. Oke, maybe you can test.
Halo.
Belum masuk. Belum masuk. Belum masuk sound yang ini.
Wait, you can hear me now.
Yes.
I do not mind at all.
Maybe you can test.
Hello? Hello?
Okay.
Yes.
Yes.
Wait, let me... In here?
Okay. If you want to off, you can click. This is on.
Hello? Okay. Hello? Hello? Hello?
Itu sudah on. Kalau mau dimatikan, tinggal dipencet dimatikan.
Is it on now?
It's on now, yes.
On now.
If you press the button, and this will be on. Yes. Yes, you can speak. It's very loud. This is from my home.
Thank you very
I
much.
just panen. Harvesting the, we call it, what's it, jambu.
I never... But can I eat it?
Yes.
Cek. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Warm greetings to all of us. Welcome to the event Ramin SERIES-54 with the theme Bamboo Revolution, Advancing Non-Timber Forest Products for Structural and Architectural Applications. First of all, we would like to welcome the Honorable Dean of the Faculty of Forestry, Tanjung Pura University, Mrs. Dr. Insinyur Farhadiba Esut MSc IPU. The Honorable, the Vice Dean for Student Affairs and Alumni. The Honorable, lecturers and educational staff of the Faculty of Forestry. The Honorable, Founder and Director of Atelier 1, United Kingdom, Professor Neil Thomas, as well as all participating in the event and all distinguished guests whom we cannot mention individually. First of all, praise and gratitude to Allah Subhanahu wa Ta'ala, who has given us all the opportunity and health today. Entering the first agenda, the singing of the Indonesian national anthem, Indonesia Raya, followed by the Rimbawan March. Ladies and gentlemen, please stand.
Di sana Mahkamah tempat kita bekerja. Rimba raya, indah permai dan mulia. Mahkamah tempat kita bekerja. Rimba raya, maha indah, cantik molek perkasa, menghibur hati sesak penyambang nusa dan bangsa. Rimba raya mulia, itulah kita kerja di sinar matahari. Gunung lembah berduri haruslah kita arungi dengan hati yang murni. Rimba raya, indah permai dan mulia. Mahkamah tempat kita bekerja. Rimba raya, indah permai dan mulia. Mahkamah tempat kita bekerja. Pagi petang, siang malam, rimba kita berseru. Bersatulah bersatu, tinggi rendah jadi satu, pertolongan selalu. Jauhkanlah sikap kami yang mementingkan diri. Ingatlah nusa bangsa, minta supaya dibela oleh kamu semua. Rimba raya, indah permai dan mulia. Mahkamah tempat kita bekerja. Rimba raya, indah permai dan mulia. Mahkamah tempat kita bekerja.
Ladies and gentlemen, you may be seated. To bless our gathering today, let us take a moment for a prayer.
Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi dan salam sejahtera bagi kita semua. Sebelum memulai kegiatan pada hari ini, marilah kita berdoa menurut agama dan kepercayaan masing-masing. Dan bagi yang beragama Islam, izinkanlah saya memimpinnya. A'udzubillahi minasyaitonirrajim. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin. Hamdan syakirin, hamdan naimin, hamdan yu'afinahu yakum jidah. Ya Rabbana lakal hamdu kama yanbaghi li jali wajhika karimu azimi sultanik. Ya Allah, Tuhan yang Maha Kuasa, pada hari ini kami berkumpul dalam rangka Ramin SERIES-54 dengan hati yang penuh syukur atas segala nikmat dan karunia-Mu. Kami memohon kepadamu agar Engkau senantiasa memberikan bimbingan dan petunjuk-Mu dalam setiap langkah yang kami ambil hari ini. Ya Allah, limpahkanlah rahmat dan berkah-Mu kepada kami, para peserta, para pembimbing, dan seluruh tim yang terlibat dalam kegiatan ini. Ya Allah, bukakanlah hati dan pikiran kami untuk menerima setiap pelajaran dan pengalaman yang berharga selama kegiatan ini. Jadikanlah kami hamba-hamba-Mu yang selalu bersemangat dalam belajar dan bekerja, serta mampu menghadapi setiap tantangan dan penuh kesabaran dan kebijaksanaan. Ya Allah, jadikanlah kegiatan ini sebagai jalan untuk mempererat tali silaturahmi ayah antara kami, memperkokoh kebersamaan, serta meningkatkan semangat kerjasama dalam mencapai tujuan bersama. Ya Allah, jauhkanlah kami dari segala rintangan dan hambatan yang dapat mengganggu kelancaran acara ini. Berilah kami kekuatan dan keikhlasan dalam menjalani setiap proses dan tanggung jawab yang kami emban. Ya Allah, ampunilah segala dosa dan kesalahan kami, baik yang disengaja maupun yang tidak disengaja. Jadikanlah usaha dan ikhtiar kami dalam kegiatan ini sebagai amal ibadah yang Engkau terima. Dengan segala kerendahan hati, kami mohon kepadamu, kabulkanlah doa dan harapan kami, berkalilah acara ini dari awal hingga akhir, dan jadikanlah hasilnya bermanfaat bagi kami semua. Amin ya rabbal alamin. Rabbana zolamna anfusana wa ilan tafir lana wa tarhamna lanakunanna minal khasirin. Rabbana atina fid dunya hasanah wa bil akhirati hasanah wa qina adzabannar. Subhana rabbil izzati amma yasifun wa salamun alal mursalin walhamdulillahi rabbil alamin. Assalamualaikum warahmatullahi wabarakatuh.
Next, the welcome speech and official opening of the event will be delivered by the Dean of the Faculty of Forestry, Tanjung Pura University, Mrs. Dr. Insinyur Farah Diba SUT MSI IPU. The floor is yours.
Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi semuanya. Salam rimba. The Honorable Professor Neil Thomas from Atelier 1, United Kingdom. So welcome to our forestry faculty today. Thank you for your coming to give a general lecture for our student. The Honorable Ibu Hafsah, thank you for accompanying Prof. Neil today. And the Honorable the Vice Dean of the Forestry Faculty, Tanjung Pura University. We have Bu Reina here, a Vice Dean for the Student Affairs, and also the Honorable the Lecturer of the Forestry Faculty. As a moderator today is Dr. Sari Delviana Marbun, and Bapak Insinyur Muhammad Dirhamsa MP. He is also a lecturer from the non-timber forest product and also bamboo also. So we have major of the one major that title is non-timber forest product, and this in this lecture we also teaching the student about the bamboo also. So I think today the student will be give more enlightening about the bamboo, not only from the forestry side but also from the architectural side and also from other sides on utilizing the bamboo. And today, Prof. Neil, the student is not only from forestry faculty, but also student from civil engineering and from architecture. Yeah, so student from architecture, maybe you can raise your hand. Yeah, okay, from civil engineering. Okay, so because they also study about bamboo for the structural construction material. So I hope all the students will be give more benefit from this general lecture. We call this general lecture is Ramin series. Ramin is a very endemic tree in West Kalimantan, a very strong tree, and this title Ramin is consists of the, in bahasa we call it seminar from the Praktisi and Industri. So welcome to all participants, and thank you, Prof. Neil, for your coming today. And with Bismillahirrahmanirrahim, we open the Ramin series for the general lecture from Professor Neil Thomas today. Okay, thank you, dan Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi. Salam rimba.
Next, we will have a group photo session. We kindly invite everyone to come forward. Kami mohon untuk teman-teman bisa Teman-teman diharap untuk berdiri. Ladies and gentlemen, next presentation by Professor Neil Thomas to Dr. Sari Delviana Marbun, Esut MSI, is invited to guide this session. Thank you.
Cek, cek. Oke. Assalamualaikum, shalom, salam sejahtera, Om Swastiastu, Namo Buddhaya, salam kebajikan. Good morning, everyone. Okay, today we will get great lecture from Professor Neil Thomas entitled Bamboo Revolution: Advancing Non-Timber Forest Products for Structural and Architectural Application. But before Prof. Neil give the lecture, I will read his curriculum vitae first. Okay, Prof. Neil Thomas is a visiting lecturer at Yale University, MIT, Imperial College in London, which are one of the top universities in the world. And he is also the director and founder of the Atelier One. You may Googling it and find many things about Atelier One. He has widely celebrated for his groundbreaking contribution to architecture and structural engineering. In 2014, he was elected a Royal Designer for Industry, RDI, one of the UK's highest honors for designers, recognizing his inventive approach to engineering. At the same year, he received an honorary fellowship from the Royal Institute of British Architects for his lasting impact on the built environment. In 2015, he was named a Fellow of the Institution of Structural Engineering, followed by the award of an MBE in 2016 for services for architecture, design, and engineering. And in 2019, he received the IABSE Medal, celebrating his outstanding contribution to structural design. And most recently, in 2025, Neil was awarded the SEWC Ronald Sharp Medal, honoring his international influence and innovation in sustainable engineering. So today, we will please give applause to Professor Neil. Time and floor are yours, Professor. Your time is 1 hour and 15 minutes.
Okay, thank you. Can you hear me? Yes. Thank you, Dr. Sari. You're going to help me, right? Because I'm going to speak in English, and then Dr. Sari is going to translate. Not everybody speaks English, right? Okay, good. Thank you to the Dean for inviting me, and Habsa for arranging, and thank you all for coming. You're not going to translate?
I will translate. Maybe in 5 minutes you speak, and I will translate it for
Okay.
the participants.
So, I'm very happy. I'm an engineer. Very happy to see engineers here, and architects. I'm also an architect. I studied both architecture and engineering. And this is a very important quotation you can see here. if you can, I can read it to you, and then perhaps you could do it from George Bernard Shaw. It says, "You see things and you say why, but I dream things that never were, and I say why not." So it's very important, you're young, you're starting out your careers, that you dream about every possibility, all the possibilities. The future now belongs to you, not to me. I'm older, right? I have a little time left to do what I do, and I will continue to do it. But I've changed very much the things I do. And I'm going to show you the two parts of what I do. Okay?
Ya, sebagai orang muda bermimpilah. Oke, you make it. I will make it short.
Okay. That was very short.
Prof. Neil sampaikan bahwa kita perlu bermimpi supaya banyak hal yang bisa kita kerjakan. Menurut beliau sudah tua, saatnya kalian yang masih muda.
Thank you. So it's possible as an engineer to make magic a little bit, right? And as an engineer, you wear different hats, have different roles. This is a sculpture of a baby. This is not yet bamboo. I'm going to talk about where I led, the work I did, which led to me being involved with bamboo, right? This is working with artists. So this is creating a sculpture of a baby. And this is the artist, it's his baby, and they scanned the baby, then made a very large model of it. And this is being built in Spain. And this is the width of this room, I guess. And then like the human body, to make it work, we needed to add a spine on the inside. Because the one thing you have that we now, I personally do, and we as a practice do, is look to nature for inspiration all the time. Nature is a very good engineer, and it's been a very good engineer for a very long time. And once you see these things in nature, you will find things that are really quite amazing. Do you engineers work, you look at the engineering of trees and plants and things, not just like wood, you're looking at the kind of nature itself, right? Yes? Okay, good. So a spine, and then they make a very thin skin around it and put the spine in, wrap it all up, and then they take it to site. But it sits just on its hand, right? And it weighs 10 tons. But it just sits there on its hands. It's almost like magic. It looks like it weighs nothing.
Is it from the bamboo? The scalp of the, is it from the bamboo?
No, I'm not talking about bamboo yet. I will talk about bamboo in a minute. This is steel and bronze. And this is a very famous sculpture. Do you know this sculpture in Chicago? This is called Cloud Gate. But what's interesting about, same idea, a very thin skin around a frame. But when they delivered it, and this is very important to explain, when they delivered it into place, it arrived early and they dropped it into place, but then there's something wrong with the sculpture. Can you see what that is? Can you ask them, what's wrong with the sculpture? Can you see?
Apa yang menurut para partisipan, apa yang salah dengan strukturnya?
Can you see anything?
Apakah ada yang bisa melihatnya?
So, you can see here the lines of when we connected all the pieces together, the lines that exist. It arrived, it was late, and so they had to deliver it in. But then, after the opening, they covered it over and they polished it for 1 year. Can you explain that? Because that's quite important.
What is the wrong?
They polished it for 1 year.
They polished it in 1 year.
For 1 whole year.
1 whole year.
Yes.
Jadi di polish, what is in Indonesia polish? Dipoles.
Okay.
Di amplas. Yep.
And then it looked like that. And sometimes it's possible as an engineer to be asked to play with things that you do when you're a child. You all know what Lego is, right? You know Lego? Okay, great. So I'm going to show you a piece of film, and this man said, we build Lego when you're a child, and you build houses this big, but they wanted to build a full-size house from Lego.
This is a joy that simply never diminishes. It is the world's premier rapid-fire reusable over 300 billion of these have been produced. And for what? And for what? For this? I think we can do better. Right, I'm confident that it works. Right, I'm confident that it works. Look at it. Look at it. I'm now going upstairs in a Lego house. This is just fantastic. I thought we might manage a bungalow or a beach hut or something. The first floor. Look at the stripes. It's just. Look at the stripes. It's just. I mean, all houses should look like this. I mean, all houses should look like this. Carpet. Cheerful. Look at my carpet. Beautiful.
So, anybody guess how many bricks? How many? 4.5 million. 4.5 million bricks. Also, as an engineer, you get the opportunity to dream, to think about ideas, and to go back to school and learn again. I continue to learn all the time. And it's very important we all recognize that. And as part of, but you don't just learn in college, you carry on learning and you keep going. So we were asked whether we could make a rainbow, but I didn't know anything about rainbows. Do you know anything about rainbows? So there are 3 things in a rainbow to make a rainbow. One is water, one is light, and one is the observer. I need to explain that? No, you don't need. They can understand. But it's very important. When a rainbow happens, the sun is always behind you, right? Because the light from the sun travels parallel, and it meets the water in front of you, and it refracts, changes angle, and reflects back out, but always at an angle of 42 degrees. So if I am standing here and the sun is here and the water's here, it creates an arc of 42 degrees. But sunlight is in 7 parts, and the angle of refraction is just very slightly different for each light.
Jadi Prof. Neil sedang menceritakan tentang fenomena terjadinya pelangi, dan fenomena ini tidak bisa terjadi sembarangan. Ada derajat yang perlu dicapai untuk bisa membentuk pelangi. Jadi ketika kita berdiri di sini lalu ada matahari, dan matahari itu akan terkena ke dinding dengan sudut tertentu, maka dia akan membentuk pelangi.
And so we made a wall of water and a bank of lights to represent the sun, and then made a rainbow. And the reason you see the arc of a rainbow like this is because it's a circle, but the other half's beneath the ground, because you're the observer in the middle of the cone. And you need to be able to understand how to build. If you're engineering, particularly if you're working with materials, it's very important. So we've done a lot of rock and roll tours like these, where you have to take structure, put it together, take it apart. This is a film of Pink Floyd in London. The interesting thing is, this sphere, which is rotating and it unfolds, it's about the level of engineering and thought, and then you have to be able to take these structures and move them from place to place. So you have to think differently all the time. Rolling Stones. You heard of the Rolling Stones? They have a bridge that extends 100 meters. I'm trying to give you an idea of the sorts of things that I've done in the past. And all of this work in these rock and roll tours, we did with a man called Mark Fisher.
So this is your work.
Yes, so we engineered rock and roll tours, including, this is the U2 band, for which we did the first big LED screen.
Jadi Prof. Neil sedang memperlihatkan berbagai karya beliau, khususnya tadi ada To Rock and Roll ya. Itu adalah karya beliau yang dikerjakan bersama dengan Mark Fisher di video tadi, dan partisipan bisa melihat betapa bagusnya karya tersebut dengan struktur yang sangat baik begitu.
And lots of different tours with the same guy. And the last tour we ever did with this guy is this tour called U2 360. It's 360-degree show. This is 70 meters across. This is steel work and a bunch of other stuff, traveling. But it's a huge undertaking. And I can just show you a very brief film of the installation of it, which is kind of interesting because you see how complicated it is to build a show that lasts for one night. And sometimes you have to do particular pieces, like this man that we worked on, who comes out from the stage. And remember, you have to move the thing around. So it's on a truck, wheeling. And this is the man who drives the kind of piece of machinery, sat in the body of it, and folded, ready to go. But because it's theatre, it's very interesting that it's not done particularly well. You see, this is the hand and the arm of the thing from fiberglass, but not painted particularly well. But when, in the context of the show, you see it, it's kind of understanding the nature of context and what something looks like.
Iya, ini tadi sebelumnya masih dibuat bagian-bagiannya dan belum dicat, belum kelihatan bagus, tapi setelah dirangkai lalu dilakukan finishing dan terlihat sangat bagus sekali.
The future is ours to find. Future is ours to find. Can you see? Can you see it in my eyes? Can you feel my eyes? Can you feel it? Can you hold it in your arms? Can you hold it in your arms?
moved from just shows to Olympic ceremonies. So we've now worked on a number of Olympic ceremonies, including London, which is very successful. And you can see the scale of sort of objects and things we're moving now. So what's very important about these projects is they are teams. People work as teams. Very, very important. So understanding the nature of materials and understanding collaboration. Whenever you do projects together.
Yeah.
Because you will benefit from understanding what it is to be a team. So you know Mary Poppins? You ever heard of Mary Poppins? We flew 42 Mary Poppins in the air.
So the team is very important to build this one.
But I want to move to, sorry. I want to move just to this now. The project that really changed, for us anyway, a lot of the work we do. This is 20 years ago, and we were working on Gardens by the Bay in Singapore, which looks like that, which is a 50-hectare garden in Singapore, and it's been very,
One city where that idea is being applied on a major scale. Singapore. 2 million trees have been planted here in the last 45 years. This city is now richer in species than any other in the world. And this practice extends to all parts of the city. The waterways have been cleaned up, and smooth-coated otters are coming back. But perhaps the most spectacular example of city greening is this grove of super trees. These 150 feet high metal structures are now full of life. Creepers have been planted to grow over the outermost branches. This is a new urban world that we have now designed and built with others in mind. Create the space and the animals will come.
Jadi Garden the Way yang terkenal di Singapura itu adalah karya.
Is this a vision of our cities of the future?
Atelier 1.
So, the point being, over my career, we've done a lot of work. I showed you projects with art projects, rock and roll tours, understanding the nature of materials. The one that changed my life, really, fundamentally, was the one I just showed you, Gardens by the Bay in Singapore. When we were working on the last rock and roll tour with Mark Fisher, the guy who had designed all those rock and roll tours, he was dying. And he said to me in an email 2 things. He said, I wished we'd got drunk together a few more times. And he said, go and find John Hardy. And this man is John Hardy. Can you switch the presentation over, please?
Switch the presentation, presentasi yang kedua.
John Hardy changed my life completely. We were working in projects, timber projects, a whole bunch of projects we were doing. And remember, when I began as an engineer 30 years ago, sustainability did not exist.
So,
Nobody knew this. Nobody talked about sustainability. It didn't matter. We just built stuff.
Jadi ada kolega beliau bernama John Hardy yang memberi sumbangsi untuk mengubahkan pola pikir sampai akhirnya beliau 30 tahun yang lalu kalau bicara tentang engineering itu belum ada bicara tentang sustainability.
But life is different. And we have messed with the planet, right? And again, the point why I'm really honored to be in a place like this is because if we don't begin to learn to live with nature and understand and be part of nature, then we're never going to fix anything. And it's fundamental. Can you say that?
Pardon me?
That we need to learn to live and work with nature.
Oh, kita perlu belajar untuk hidup bersama dengan alam.
And apart from working with timber, my introduction to the world of nature was bamboo. And I first went to Bali 12 years ago. And I was introduced to bamboo by this man.
Jadi
John
Pak
Hardy.
John Hardy ini yang memperkenalkan bambu kepada Prof. Neil, sehingga akhirnya beliau juga mulai bekerja membuat berbagai karya dari bambu.
And John Hardy has a family in Bali and he needed a school for his children, couldn't find one and built his own school.
John
This is the
Hardy
green school.
membangun sebuah sekolah, a school di Bali. Dan ini adalah sekolahnya, jadi seperti a dream school, sekolah yang diharapkan. Gitu.
It is a school built entirely from bamboo
Okay. In Bali, right?
in Bali.
Okay.
And all bamboo. And I returned to England when I'd been there for a few days, and I told my office that we would be working on the design of bamboo. People thought I was joking.
Okay.
They thought it was a joke.
Ketika Prof. Neil kembali ke Inggris, kemudian dia berkata kepada koleganya yang di kantor untuk kita mulai bekerja di bambu. Kemudian koleganya mulai menganggap bahwa Prof. Neil itu sedang bercanda, not serious.
And 12 years later, I will show you what that looks like. So I don't know how much you do or don't know about bamboo, but bamboo looks like this. It grows in clumps, in groups, and the bamboo is a long shaft and kind of has leaves at the top that do this photosynthesis. It has an interesting form of structure because that tube...
Yeah.
Has anybody got a piece of paper? We've got a piece of paper? Anybody? Just, yeah, that'll do. Thank you. Now, can I take it out there?
Check.
You see this? Right. This is a material, right? It doesn't matter what it is, it's paper, happens to be paper. But it's got no stiffness, no strength, right? No strength. But if I do this to it, if I do that to it, now it's strong. Yeah. It's a tube. You've done nothing but change the shape. Same material, it's a tube. So bamboo is a tube, grows as a tube, very, very strong, right? Very efficient. But it also has these, does it shine on there? No. It has these diaphragms that grow up within it. And if you design a tube this is a tube, right? If I push on the top and on the bottom, what it does is buckle. It buckles. You understand that? It breaks, bends sideways. These diaphragms stop that happening. It's unbelievable as a material, absolutely unbelievable.
Jadi bambu itu seperti tube, tapi ada bagian bukunya. So most of the students actually already understand about the.
Okay, good. It grows in South America, mainly in the southern part of the globe, Africa and Asia. It grows over 2/3 of the planet, and there are 1,600 species. You know all this, right? In the building industry, the building industry produces 40% of greenhouse gases on the planet.
40%.
40%. Which is very important, because it's the greenhouse gases, you understand how the greenhouse works, right?
Yeah.
it heats, it creates a layer so that the heat can no longer get out. And the heat can't get out, it heats up. And the planet is heating up. Everybody accepts that, right? There's no argument about that.
Jadi
So-
40% gas rumah kaca itu berasal dari bangunan.
And the production, in the UK, the government have pledged to reduce carbon emissions by 40% by 2030. 2030, that's in 4 years' time. And basically, the production of carbon in the process of building goes from extracting whatever material you have, manufactured, transported to site, the construction of it, its life, and whatever happens at the end of its life. And in a conventional building, embodied carbon is the carbon within the material itself. You understand that? Everybody got that?
Pardon me?
Embodied carbon is the
Embodied
carbon dioxide that is taken within the production of a material.
Karbon yang tersimpan, yang ada dalam sebuah material, itu adalah karbon yang tersimpan selama material itu masih dipakai.
And operational carbon is the carbon that's produced in the life of a building. So it has a cycle looking like that. So it's the lighting, the stuff that you see every day. So the air conditioning, lighting, power, communications, everything. And domestic operational carbon, same thing. But we've begun to control the operational carbon in buildings because we build buildings better.
Selain embedded carbon, ada juga operation carbon, adalah karbon yang diproduksi selama bangunan itu ada aktivitasnya, misalnya listrik atau segala kegiatan yang menghasilkan karbon.
But so you need to think about the materials you produce buildings with. A steel structure, when you're in the manufacture and production of it, you produce a lot of carbon dioxide in the process of making the steel, right? So hence it's red and negative. In concrete, it's even more than producing steel, right? So at the beginning of a 50-year life, there's this whole negative carbon where you've produced all this carbon dioxide that's gone into the atmosphere. You can't do anything about it. Wood, the other argument being, is that wood takes in carbon dioxide and breathes out oxygen. So you're sequestering carbon. Is that a phrase you know and understand, right?
Pardon me, the steel and concrete, they
Produce carbon dioxide
carbon
into
in
the
the
atmosphere.
beginning.
Oh, yeah, in the production of
In the
them.
production,
Yeah.
the beginning of the production. Jadi kalau kita membuat bangunan yang berasal dari steel atau concrete, kita itu menghasilkan banyak karbon ketika proses produksinya. Selayaknya kita menggali atau mengekstrak bahan-bahan tersebut, jadi kita sudah mengeluarkan karbon sejak produksi di awal. Tetapi kalau kayu, bahan-bahan alam, salah satunya adalah bambu, selama hidup dia justru menyerap karbon dan menyimpannya, gitu ya. Dan akan dikeluarkan ketika sudah beberapa puluh tahun kita gunakan, atau mungkin yang kita kenal dengan setelah terjadi dekomposisi.
And so timber, it takes up carbon dioxide from the atmosphere. So it helps reducing the amount of carbon dioxide. However, it only does it, timber grows 20, 30, possibly 50 years. It takes a tree to grow,
Ya.
right?
Dan ketika bahan alam tersebut seperti kayu atau bambu misalnya, selama dia hidup berapa tahun, selama itu juga dia menyerap karbon dari alam.
But bamboo grows in 5 years.
Oh ya.
So you understand the difference. In this, timber grows and you can pull in so much carbon dioxide in the growth, but over a very long period. But bamboo grows really quickly.
Yeah, 5 years.
And therefore, you're able to pull in more carbon dioxide, which is very good for the atmosphere and very good for the planet.
Ya. Kayak kalau kayu, baik itu softwood maupun hardwood, dia perlu waktu puluhan tahun. Yang kita masukkan di sini adalah yang konvensional ya. Puluhan tahun menyerap karbon dari atmosfer, sementara bambu itu setiap 5 tahun dia bisa kita harvest, kita panen, dan setiap 5 tahun kita bisa mendapatkan hasilnya.
And bamboo, as you know, it grows from, so in South America they use guadua, in Asia it's more materials like moso and Dendroclamus asper, but the kind of basic principle is the same. They grow roughly full size in a year, and then they mature to 3 or 4 years afterwards, and then they harvest them.
Actually, in Kalimantan we have many species in bamboo.
Bambusa vulgaris is the major one.
Pardon me?
Kalimantan, you have vulgaris is the major buildable one, I believe.
Yeah.
Bambusa vulgaris.
Full garage, yeah.
Yeah. That's what I understand is in this part of the world,
Okay.
which is a good one.
Yeah.
But I'm just explaining about the others. But it doesn't matter. The vulgaris grows the same rate, but it grows very quickly and matures over 3 or 4 years.
Yeah.
And then you harvest it. But you can only harvest a proportion of the bamboo at any one time. You have to be very careful about the way you control the growth and harvesting of bamboo. So if you have 60 clumps per hectare, and over an area of 60 clumps, you have per 5 meters by 5 meters, 60 columns per clump, and a clump is 5 by 5, right? Which means you have 400 clumps per hectare, and that means you can grow, and this is asper, which is a patung bamboo, but you know it's patung, I think. So density of 400 clumps per hectare in managed plantations. That means you can sequester carbon 37.5 tons per hectare per year and release oxygen 100 tons per hectare per year. Remembering that all of the buildings that you build in steel and concrete and anything else are all putting carbon into the air, carbon dioxide into the air, and other greenhouse gases. Here you're taking it out and releasing oxygen. This has to be a direction in construction that we will take as a world, as a planet. Just very recently, a new design manual was produced for bamboo, which came out. So when I first started working with bamboo, there were only 2 codes of practice. One from China and one from Colombia. We've just launched in the UK a manual for the design of bamboo structures. So it is growing and expanding at a big rate. And so this is the manual for the design to ISO 22156, which you can use anywhere around the planet. But what can you do with that? And I'm going to show you, these are buildings. I said to you, we've been working, they told me 12 years ago it was a joke. This building is the Ark at the Green School in Bali, the same school John Hardy took his daughters to, sent his children. In 2022, we won the Institution of Structural Engineers Supreme Award for this building, which is built from bamboo, entirely and only from bamboo, and it also received the Sustainability Award, and they said, you want to read that in, can they read that? The project demonstrates the exciting possibility as bamboo as a potential mainstream building material. Architects and engineers alike should be inspired.
Jadi ini adalah salah satu karya beliau di sekolah. What school? The name of the school?
The Green School in Bali.
The Green School in Bali, ada satu sekolah, adalah hasil karya beliau. dan mendapatkan beberapa penghargaan. Ini penghargaan Structural Awards 2022.
Yes.
2022 awarded for advancing, jadi diberi penghargaan untuk advancing the structural application of low carbon materials. Jadi membuat membuat bangunan dari material yang low carbon, rendah karbon.
And we've gone on to do other buildings. This is a big, very famous yoga shala now. These are in South America. This is in Costa Rica. A building that we did with a company called Ibuku Designers. And these I'm very proud of, because these, we went out and took leaves and gave the leaves to the client and said, we can make structures like the leaves. These are based upon leaves. They're very small diameter bamboo, but this thing I was talking to you about the stiffness, this thing here, it's the same idea, right? This is not stiff, but you give it shape, now it's stiff. So we did exactly the same thing. Nature does it really well. Go and look. You will see it every day in front of you.
So you imitate leaves for the structure?
Yes.
Oh, jadi karya-karya beliau ini terinspirasi dari desain-desain yang ada di alam. Misalnya seperti daun, lalu beliau membuat karya seperti yang kalian lihat di layar. Ini adalah terinspirasi dari bentuk daun, begitu.
And here, these are in the Philippines. And this is the windiest place on the earth. Does that need translating?
Pardon me?
The windiest.
The windiest. Oh, tempat yang paling, salah satu tempat yang paling berangin. Jadi karena terbuka, jadi anginnya banyak.
So here we had to combine steel with bamboo to create structures that allowed it to exist in very, very high wind speeds.
Kalian bisa bayangkan kalau kita ada di situ, sangat healing sekali ya.
And not only are we building buildings, but we're developing ideas with bamboo. Bamboo has something amazing that's possible. When we were doing the green school, because I told you the codes of practice were limited, we were doing testing like this. So just literally in the same place we were building, we were testing sections of the building. But to form the curves, they use this technique where they cut the bamboo and then fold it, right? This is stupid. This is a stupid idea. I've explained to you why bamboo is such a good structure, and then you cut it. So, but we discovered with bamboo, it has something really interesting about it. Bamboo can grow curved, right? Generally, it grows straight up. But because it's trying to find the sun, because it wants to grow, to photosynthesize, it kind of grows outwards as well. So it's growing curved. And in fact, you can train bamboo to grow curved, right?
Ya, ya.
You're aware of this.
Jadi karena bambu itu kalau kita lihat memang tumbuhnya vertikal, tetapi pada waktu tertentu ketika batangnya sudah terlalu tinggi dia akan curve. Wait a minute.
But
Melengkung. Jadi itulah yang menjadi dasar beliau juga membuat karya-karyanya bambu itu melengkung, begitu. Karena ada karakteristik itu dari bambu.
okay.
Yep.
But how? How can it do that?
Yeah.
The thing is, if you take a piece of, if you take something stiff and bend it,
Yeah.
it's called elastic bending,
Yeah.
right?
Yeah.
Or cold bending.
Yeah. We
That needs
also-
explaining, or they understand?
Ya, jadi kalau baterai alam, actually we also learn it in our students.
Elastic bending. Okay.
Material alam itu bisa dilengkungkan karena ada sifat elastisnya. Bagi yang sudah belajar di peningkatan kualitas kayu pasti sudah pernah dengar ya. ada sifat elastisnya. Itulah kenapa kayu, bambu bisa dilengkungkan.
And it's possible, therefore, to create these three-dimensional surfaces that I'm talking about by bending individual members, just like that, elastically. But there is a limit to what you can do with elastic bending.
Ya, tetapi setiap material alam itu ada batasnya. Batas seberapa besar pressure yang kita berikan untuk dia bisa bending.
Exactly.
Yep.
And here you can see what's happening. You bend and bend like this, and actually, no, it's this. This is me bending foam. You see what's happening there? You bend it like this, and the upper part's getting shorter, and the bottom part's getting longer.
Yeah.
Right? Compression, tension. Bend, bend, bend. But if you bend it too far, if you keep bending, it breaks.
Yeah.
Right? So you have to design within the limit of the capacity of the bamboo. You understand? Make sense?
Ya, ketika kita melengkungkan bambu, ada bagian yang kena gaya tarik, ada bagian yang kena gaya tekan. Yang kena gaya tekan dia akan mengecil, yang kena gaya tarik dia akan memanjang. Tetapi ini semua ada batasnya. Jadi ketika kita memberikan pressure too much, dia akan break, dia akan patah gitu ya, dan rusak.
But that's not true, is it? Because these radii here are really, really tight radii. This is really tight. It's massive, huge, but yet it's very, very tight. So something else is happening.
Ya. Tetapi untuk kasus yang ini, yang tadi melingkar cukup banyak, sebenarnya itu abnormal ya. Berarti ada sesuatu yang terjadi. Kenapa akhirnya dia bisa membentuk lengkungan yang begitu ekstrim?
So, but to understand what is happening, you need to look very closely at what the bamboo is. And this is how bamboo grows, right?
Yeah.
When a tree comes from the ground, it grows like this. This is a tree growing, right? This is 1 year of tree growth, and then the next year, another layer, the next year, another layer, next year, another layer. And it grows up, but it also grows out, right?
Yep.
That's why you get rings in a tree. It's 1 year growth, 1 year growth, 1 year growth. So you get these rings, right? Bamboo does not do that.
Ya. Jadi pola pertumbuhan bambu dengan pola pertumbuhan kayu itu berbeda. Mungkin yang sudah mendapatkan struktur kayu sudah mendapatkannya. Kalau kayu itu selama bertumbuh dia mengalami pertumbuhan primer dan pertumbuhan sekunder setiap tahun, tetapi bambu tidak mengalami pertumbuhan yang sama dengan kayu.
Bamboo grows straight. It's here. All of these diaphragms that I talked about are formed in the rhizome beneath the ground. And when it comes out of the ground, it is full size. And so it grows like that only. It doesn't grow outwards. Only up. It's very important.
Jadi bambu itu perbedaannya dengan kayu adalah pertumbuhannya itu hanya pertumbuhan primer. Jadi tidak ada pertumbuhan sekunder. Makanya kenapa bambu itu lebih silinder dibandingkan kayu-kayu yang lebih kerucut. Jadi kalau bagian pangkalnya sudah mencapai maksimal, diameter maksimal, dia tidak akan membesar kembali. Lalu yang mengalami pertumbuhan adalah bagian yang di atasnya.
And it's very important because all of the fibers, the structural fibers in the wall of the bamboo are straight. And so what you're looking at here on the left is a diagram of those fibers running longitudinally. When it comes to the diaphragm, they do something very odd. They kind of go like that, right?
Yeah.
But they're straight.
Untuk struktur kayu, actually we learn this one in structure.
Okay,
wood
good.
Structure. Untuk struktur sel-sel yang ada di dalam bambu itu secara keseluruhan itu adalah vertikal. Berbeda dengan kayu, ada yang vertikal, ada yang horizontal. Tetapi khusus di bagian bukunya, bagian node-nya itu, sel-selnya itu horizontal, tidak ada yang vertikal. Ini adalah karakteristik unik dari bambu yang harus menjadi dasar kita ketika kita mau menggunakan bambu.
So, the difference between wood on the left and bamboo on the right. The black dots on the right are the technical fibers or the structural fibers. Okay, so, and also there's something interesting that those fibers become more dense towards the outside of the culm.
Pardon me?
The fibers here, the fibers become, one second. The fibers become more dense.
Oh ya. Jadi serat di bagian pinggir itu jauh lebih padat dibandingkan bagian dekat bagian kolomnya, bagian tengahnya gitu.
So on the wood you have wood on the left, and so you get circumferential rings. If you go a little closer, then this is what the timber looks like on the left. So you get these growth rings every year. It means you get circumferential fibers. In bamboo, you don't get circumferential fibers. You only get these fibers called vascular bundles, and this stuff, the glue. It's glue, right? That's called parenchyma.
Parenchyma, iya. Jadi struktur bambu itu secara garis besar terdiri dari vascular bundle, disitulah seratnya tersusun, dan ada parenkim yang bersifat merekatkan antara satu vascular bundle dengan vascular bundle yang lain. Berbeda sekali dengan kayu yang seluruh selnya saling terpisah, tidak membentuk ikatan-ikatan seperti vascular bundle.
And if you go closer again, you come in and you can see in the bamboo, these fibers are all longitudinal, and you see on the timber how they cross in the other direction. So you have fibers going this way in timber and this way, and in bamboo just this way.
Ya, ini adalah dua contoh. Yang sebelah kiri tadi itu adalah 3 dimensi struktur kayu, dan sebelah kanan saya itu adalah bukan yang ini, yang sebelumnya ya, 3 dimensi struktur bambu. Jadi terlihat kalau sel kayu itu ada yang vertikal, ada yang horizontal, sementara sel dari bambu itu seluruhnya vertikal.
And if you get closer still, you see the technical fibers around the vascular bundle, and the holes in it are the vessels that transport water and nutrients, but all running longitudinally. And then you close into those technical fibers, and those technical fibers look like this.
Jadi ini adalah gambaran satu vascular bundle dari bambu, dan seluruh kegiatan silem maupun phloem terjadi di vascular bundle ini. Berbeda dengan kayu, dan kalau kita lihat per satu sel, berbeda dengan kayu itu kan hanya ada dinding primer dan dinding sekunder ya. Sekunder itu juga hanya ada S1, S2. Sementara S1, S2, S3. Sementara untuk bambu itu banyak lapisannya, seperti yang terlihat di layar.
And then each of those fibers is made up of a series of annuli, circles, and each of those circles is made up of a series of very, very tiny fibers, all running in the same direction. This way, and then the next layer, this way, next layer, this way, this way, this way. Right? Everybody understand that?
Dan setiap lapisan dari serat itu punya mikrofibril yang berbeda-beda. Kalau diperhatikan, yang awal susunan mikrofibrilnya seperti ini, kemudian yang selanjutnya seperti ini, dan itu tujuannya untuk memperkuat serat dari si bambunya.
And now we get to the point.
Ya, jadi sekarang kita lihat poinnya. Kenapa Prof. Neil membahas tentang struktur sel dari bambu tersebut?
So, those fibers, each of these individual little platelets, little short fibers, are connected together by an electrical bond, which looks like this. On the left-hand side, the electrical bond on the left-hand side. Everybody got that? They lay over one another, they're connected by an electrical bond.
Serat yang satu dengan serat yang lainnya itu saling berikatan melalui ikatan Kalau di sini Prof. Neil sebutkan lignin and hemicellulose bond, adanya ikatan antara hemicellulose dan lignin, satu serat dengan serat yang lain.
So, if you heat the bamboo, then between the fibers, the glue, the parenchyma melts. Right? You can melt it between 120 and 150 degrees centigrade.
120.
Between 120 and 150 degrees centigrade.
Oh, ketika bambu dipanaskan pada suhu 120 sampai 150, maka akan parenchymnya akan melunak. Melting,
then,
right?
Huh?
Melting. Do you mean melting?
You melt.
You
yes.
melt the
melt
parenchyma. The parenchyma.
The glue in
The
between.
glue between the
The
fibers.
technical fibers.
Okay.
And then what happens is, this is a technical fiber. Now you've melted the glue around it, and then you bend it, and it just pulls the electrical bond.
Okay. Yeah.
But the fibers, no shear resistance.
Okay. Seperti yang diajarkan di peningkatan kualitas kayu juga, salah satu cara melengkungkan material alam itu adalah mengukusnya atau memanaskannya supaya perekat-perekat, tanda kutip ya, perekat-perekat yang ada di dalam material tersebut bisa melunak dan akhirnya material tersebut bisa dibengkokkan begitu.
So you can take a straight bamboo, heat it, bend it, and then cool it, and now it remains curved. But there's no induced pre-stress, none.
There is no pressure,
No pressure.
just heat it,
Just
heat.
because the heat's it's cooled down now, so the heat's gone, and it just is now bent.
Oh, yeah.
No pressure inside at all.
Jadi ketika kita mau melengkungkan bambu, kita panaskan dulu, baru kita bentuk sesuai dengan lengkungan yang kita harapkan, kemudian didinginkan, dia akan melengkung seperti yang digambar tadi.
This is very interesting. You know, you got all this, right? You knew all this.
This is very what?
You knew this, understood this process.
Some of the students already knew this because I already taught them about the bending one. In
The
my
cold bending,
Yeah.
not the heat bending.
I taught them about heat the material, the natural material. In this case, wood. We heat it in 100.
Yeah, wood can do it, yes.
And then we bend it with any form, and then cool it, and then we get the curved wood.
So, but it's a very important potential for bamboo, and I will show you an example. This is a bus station in Kampala in Uganda, and we were asked to design a new bus station for them, and we began to look at the way flowers work. This is the shape of the bus station they wanted, these kind of brown, they wanted these sort of cones, and then a roof over the top, right?
Jadi ilmu bending bambu tadi kemudian diaplikasikan beliau untuk membuat satu karya di Uganda. Is it Uganda? Uganda?
Uganda.
Uganda, ya, di Uganda di Afrika, dan beliau imitasi pola dari bunga ini untuk membuat what is that? Bus station.
Bus station,
Yeah.
yes. And we began to look at the way flowers work. Flowers work, because when we as engineers analyze things, we like to make everything square and compact, but right in grids, because that suits the way we think. But that isn't how it works. That is not how nature works, nothing like that. This is the form of the flower. If we analyze a cone on the left-hand side, when you make finite element analysis, you discretize, right, the surface.
Pardon me?
You make it into small chunks for finite element analysis.
Okay.
Anyway, this is the analysis of a straight cone, but this is what the kind of cone when you use what is called principal stress. So you allow the stress not to follow the design of a piece of software, but what it actually is. on the right-hand side is what the forces look like. And if you design a slab, a square slab in a room, in a building, we reinforce it with square meshes because that's what we manufacture and it's easy. But the forces in it look like that. That's really the blue and the red are the way the forces are. And you can build that like that, but it's very complicated. But if we take that same cone that I was talking about and reanalyze again, under the load of wind, that's what the forces look like. And then you analyze for wind in 4 directions, this is what the stresses in it look like. And we said, for the bus station, what if we start looking at these 3-dimensional surfaces and we analyze them for principal stress, and that's what the forces look like, and that's what the canopy looks like. Now, if we were doing this in steel, it would be very complicated. But bamboo, you build one element at a time. So it is possible to actually create this roof from bamboo. And using 2 different colors following principal stresses, you create a structure that follows the way nature allows the forces to go.
Ini adalah karya beliau. Dan sebelum beliau membuat ini, tadinya beliau melihat bunga yang tadi, lalu menghitung atau memperkirakan stresnya ada di mana, lalu menggunakan the curve bambu yang sudah dilengkungkan tadi untuk mengikuti pola dari alam tersebut. Dalam hal ini adalah bunga yang tadi.
And another area of development is augmented reality. We've been working on some projects in Africa. This is in Kenya. These are for some shells, and we were trying to understand how we could define the shape of these objects to build them.
Okay.
Because they are amorphous 3-dimensional surfaces. How do we define the shape? You can't define them in terms of 2D drawings, right?
So right now I'm sitting here in my virtual working environment. In front of me 2 virtual screens. One, the environment that you use to grasshopper, the environment that you use.
This is a man called Christoph Kroller at Hong Kong University, who is able to sit inside his building and design the same when he's sitting inside his building whilst designing it in augmented reality. Did you understand? So this is in our office. So we have a 3D model of the building in augmented reality using... Shall I go back and show you again? Yeah. Let me show you this again. Look, watch
So right now
him
I'm sitting here in my virtual working environment. In front of me 2 virtual screens. One with rhino on it, the other one with grasshopper. So right now I'm sitting here in my virtual working environment. In front of me 2 virtual screens. One with rhino on it, the other with grasshopper. At the same time, the environment that you use to change your creation in 1-to-1 scale. So as I'm changing parameters, I can appreciate at the same time, real time, sitting inside around creation in 1-to-1 scale. Much more. As I'm changing parameters, I can appreciate them in real time.
And we're using this technology now to enable us to producing projects now where we're not producing drawings in the conventional sense.
Oke, jadi beliau saat ini sedang producing, menghasilkan berbagai karya yang berasal dari bambu, bukan yang konvensional lagi.
So that's design areas. We're also working in phytoremediation, looking into the idea of how you can improve ground using planting. So taking old steel, we're currently working on a project in Milan, in Italy, where there's an old steelworks, where they are proposing, it's a 30-year project because the whole site is enormous. And so they build for the first 10 years, the first third of the site is built over 10 years, and the rest is being phytoremediated. So, and phytoremediation is a sustainable, cost-effective in situ technology using plants and associated microbes to remove, degrade, or contain contaminants such as heavy metals, hydrocarbons, and pesticides. And this is work that we are doing separately from the design research of engineering, structural engineering, but in terms of looking into what are the elements that you need to be able to extract contaminants on degraded sites. And there's a kind of conversation about, is it bamboo or is it, I've heard Polonia talked about, but it's not one species. We all know and understand, you understand better than me, that monocropping is really not very healthy in the long term. And you need to think about how you combine planting. And so this exercise that we've done looks at a whole bunch of materials, coffee, bamboo, one of them. Bamboo roots only grow to a certain depth. So below a certain depth, they're not very useful.
Oke, jadi Prof. Neil sedang membahas tentang fitoremediasi. Itu adalah teknologi hijau yang menggunakan tanaman atau mikroorganisme terkait untuk menyerap, menguraikan atau menstabilkan polutan seperti logam berat, pestisida ataupun limbah organik yang ada di tanah, di air ataupun di udara. Dan berbagai jenis tanaman ini salah satunya adalah bambu.
So it's a combination. So coffee, for instance, its roots are down to 1 meter, and bamboo is between 1 and 1.5, 2 meters. But things like the umbrella thorn, which goes down 6 or 7 meters. And when you look at steel sites, some of the contaminants are as much as 10 meters down. You need to look whether water's involved. So it's a very complex combination of plants to do the kind of total remediation of a site, and one that we are working on and developing.
Jadi kombinasi berbagai tanaman itu diperlukan karena kemungkinan misalnya ada beberapa tanaman yang perakarannya tidak terlalu dalam, tetapi ada polutan yang perlu diserap yang lebih dalam dari perakaran tanaman tertentu, maka kita perlu kombinasi dengan tanaman-tanaman yang lain.
And another area is carbon credits, because you can go and buy, if you extract carbon dioxide from the air, you can sell the idea of doing that. So it's possible to look at taking bamboo and again other materials, and Polonia being one of them, but bamboo grows so quickly, and I explained that earlier on, that actually it's possible to use timber. This is a building we worked on years ago, where we made the argument to the client, and the client who was in this building was the Woodland Trust. And the argument being is that you would have 360 tons of carbon dioxide produced, as opposed to 518 tons of carbon sequestered within the timber. You understand the phrase sequester?
The what?
Sequester.
Sequestance, ya. Jadi selain berkaitan tadi dengan fitoremediasi, pemanfaatan bambu juga berkaitan dengan karbon. Ya, karena bambu itu tumbuhnya cepat dan punya peluang yang baik ataupun besar untuk penyerapan karbon dari atmosfer.
So one of the big arguments with any natural materials is what happens at the end of its life. Because if you argue that you're sequestering carbon, at the end of the building life, what if you burn the building? The carbon goes into the atmosphere again. But recently in America, this group, Arias Earth, got approval for a building in Washington, at the University of Washington, to allow them to make the assumption that at the end of the life, the timber would not simply be burned, but would be reused. And this is the nature of regeneration that we need to think about. When you design buildings, you need to design buildings that they are not at the end of their life destroyed, but they are reused. It's very important.
In America.
This is in America. This has been approved. It's the first time ever as far as I understand, in North America, but the rest of the world will now follow. This is now accepted as in the UK, we have to discount sequestration of carbon on buildings, in timber buildings, because they don't know what will happen to the buildings later in their life. Now it's approved in America, so we will follow, I suspect.
Okay,
Does that make sense?
Di Amerika Utara itu mereka sudah mulai melakukan suatu program kalau misalnya bangunannya itu dari kayu itu harus di reuse ya, reuse.
Yes.
Reuse, jadi tidak boleh dibakar, gitu.
And the future, what is the future? Connections. Bamboo, one of the things that is very difficult with natural materials, timber and bamboo specifically, is how you connect them together. And it used to be, this guy, Simon Velez, the pioneer in the design of bamboo, used concrete in the ends of bamboo, or you could use steel work, but these things are not really appropriate. So we've begun to look into new connectors using the technology of bicycles.
Jadi beliau sedang menjelaskan tentang koneksi atau sambungan yang bisa dilakukan untuk bambu, gitu.
And in terms of strength, how you design the connectors. If you watch this is a pin going through the center of bamboo and bending the bamboo. Watch the force and what's happening. You're in the middle of the bamboo and you see how it splits. So the thing I showed you about it having no circumferential fibers is a benefit in being able to bend it, but it is not a benefit when you want to design for bending like this, because it splits very easily. So what we did was add a washer to the outside, and this increased the capacity of the bamboo from 3 kilonewtons to 30, 10 times the capacity, by distributing the load from the pin to the bamboo, around the bamboo. Make sense?
Jadi beliau ini melakukan suatu percobaan melumbangi bambu, lalu melakukan pengujian, begitu ya. Lalu terlihat bahwa dengan adanya lubang yang dibuat itu justru membuat bambu cepat terbelah. Lalu beliau mencoba melakukan hal yang lain. You bend it, this one.
30 kilo, sorry?
You in this picture, you bend the bamboo.
Yes, we're modeling the bending of the bamboo. So this is the bamboo bending with a pin, just only a pin through the middle. And you see it gives you 3 kilonewtons.
Yep.
And then we add the disc washer, which is attached to the bamboo on the outside, and we bend it again. You can see it bending here. And now it takes 30 kilonewtons.
Dan beliau berdasarkan percobaan yang sebelumnya, ternyata kan bambunya cepat terbelah, lalu beliau melakukan metode yang lain atau teknologi yang lain, memberikan tambahan di bagian yang lubang itu, sehingga ketika diuji kembali ada peningkatan signifikan sifat mekanisnya.
Which meant we've been able to go on and develop a modular system for construction of housing. This is a social housing system. On the left, we built 11 of them in Nicaragua, and we're now building 2 new prototypes in Mexico for housing. And we're doing this through a company called the Node Company. And here you can see the connection systems based upon bicycle connectors, which allows you to connect bamboo together easily. dry, no materials. So you need to have very little skill in manufacturing it just to be able to chop the end and drill holes in it.
Jadi, so the note company is yours?
Yes.
Yours?
Oh,
Okay.
I share it with, yes, yes.
Is it yours? The note company?
But it involves a whole bunch of other people.
Okay, yeah, but you are one of the
Owners, yes.
Oke, jadi hasil dari percobaan tadi akhirnya beliau membuat kembali satu company, namanya Note Company yang khusus merangkai bagaimana cara bambu untuk bisa disambungkan, gitu ya. Jadi setiap kali ada orang yang mau menyambungkan bambu, tinggal datang ke company beliau dan menggunakan teknologi yang sudah beliau buat, sehingga bambunya tidak cepat rusak, berdasarkan hasil penelitian yang telah beliau paparkan sebelumnya.
And then bamboo is used in composites now, so bamboo fibers are used in the design of wind turbine blades because they are lighter than carbon fiber. In fact, it means you can make more efficient turbine blades with them, so that's a big industry developing in China particularly. And the car industry, bamboo is being used in composites for the car industry, which will develop more and more. And one of the key things that came from the conversation I had about the strength of bamboo because of the fiber orientation, right?
Yeah.
Timber is reasonably good in shear, not very good in tension and compression. Maybe 20, 30 newtons per square millimeter.
Jadi beliau sedang membandingkan sifat mekanis dari bambu dan juga kayu, gitu ya. Bambu itu memang lemah di kemampuannya untuk belah, tapi kayu itu lemah di bendingnya. Jadi beliau mencoba menggabungkan kelebihan dari masing-masing material tersebut.
The bamboo is worth 2 or 3 times in tension and compression what timber is.
Bambu is 2
to 3 times better in tension and compression.
Bambu itu punya sifat 2 sampai 3 kali lebih baik dalam hal compression, sifat tekannya, gitu ya, kekuatan tekannya dibandingkan kayu.
So if you can take the shear strength of timber in the middle,
Yeah.
and the tension and compression strength of bamboo on the 2 outer faces, you get a hybrid which is better than either.
Oke, jadi dengan karakteristik antara bambu dan timber tadi, beliau menggabungkannya, menjadikannya composite hybrid. Bambu dan kayu digabungkan sehingga keunggulan dari bambu bisa didapatkan, khususnya compression. Bambu is better in compression, right?
And tension.
And
Both.
tension, but
Not so
timber,
good in shear.
But timber is better in shear.
Shear, yes.
Yeah.
So you end up being able to make a hybrid, and this is an interesting one because if you pre-curve the compression and tension cord, you can improve it again. This is something being developed in the University of Glasgow in the north of England.
Oke, jadi kalau mau menggabungkan harus mengingat karakteristik masing-masing. Karena kayu itu kuat di bagian shear-nya atau gesernya, dia harus ditaruh di bagian tengah. Karena geser ketika kita melakukan memberikan beban, geser itu paling banyak di bagian tengah, jadi kayu harus ditaruh di bagian tengah, sementara bagian atas dan bawah, tekan dan compression and tensionnya itu harus ditaruh di bagian luar.
Okay. And then the last thing is something that is, and I said this a few times, in my lifetime, bamboo will become part of the normal, the kind of general palette of materials that will be specified in the building industry in my lifetime. This will happen.
Oke. Jadi menurut beliau akan menjadikan bambu sebagai material utama selama dia hidup. Gitu.
And in case you want to know how I know that, look, this is engineered bamboo products. This is a bamboo beam been produced in the Philippines, a curved engineered bamboo beam. This building, 7 stories, is in China. This is only bamboo. This is an engineered bamboo building Complete.
In China.
In China.
Ini adalah bangunan di Cina yang sepenuhnya materialnya berasal dari bambu.
And when I began, at the beginning, I told you 10, 12 years ago, I started looking, engineered bamboo was hardly in existence. Now China is very far ahead. And I know you here, my understanding is you grow bamboo, and the kind of idea that you can develop into these industries, I think is very important now.
So you start bamboo engineering in 12 years ago.
12 years.
Jadi beliau memulai membuat karya dari bambu itu 12 tahun yang lalu, dan pada saat itu sangat susah menemukan karya-karya yang berasal dari bambu. Tapi sekarang di Cina itu sudah sangat berkembang. Dan beliau juga berharap kita yang punya banyak bambu bisa mengembangkannya juga.
And so I said, this is in China, this 7-story building. This is not engineered by us, by a man called Professor Xiao, who is a remarkable engineer. But we've just finished our first engineered bamboo building in Bali. Small one, but nonetheless, it's the first one we've done. But it's the first, I'm sure, of many. And I am saying, I'm very happy that you are studying bamboo. It will become more a part of our lives in the construction industry in the future, I promise you that.
So this is your first?
Yes, this one.
This is your first.
First
Ini adalah
engineer
karya pertama beliau ketika beliau memutuskan untuk berkarya di dunia bambu.
Okay, thank you very much indeed for inviting me. Thank you.
That's all?
Huh?
That's all?
Yes.
Okay.
Did you want more? You could do more.
Okay, that's all from Prof. Neil. Students, and maybe from the lecture, you may ask question for Professor Neil. Silahkan jika ada yang ingin bertanya. Oh, it's okay. Bu Dekan dulu ya.
Okay, thank you, Prof. Neil. It's very interesting how bamboo is very suitable not only for our carbon, for reserve the carbon, but also for the structural material. And so many very interesting building, including like the school in Bali. So I want to go there to see the school.
I can invite you.
Okay,
On behalf
so
of
much.
John Hardy, please come and stay. Yes.
Yeah. Thank you so much. It's not just, I think it's just for discussion, because we know that bamboo is not very preserved one's materials. So I mean that in Indonesia here, in tropic area, bamboo is vulnerable for some destroying wood organism. So like we call it here a kumbang here, makes some small powder from bamboo when this insect attack the bamboo. So do you have any technology through to preservation and to increase the
Durability.
yes,
Yes.
so it will be make bamboo strong to this insect and not decrease the quality of bamboo. Yeah.
So,
Thank you.
thank you for the question. Thank you. And thank you for inviting me again, by the way. Thank you very much. But 30 years ago, Linda Garland came up with the technique of borax treatment for bamboo, which removes the starch. It used to be done with water. You could soak bamboo in water and it would release the starches, the things that attract insects to it, to eat it. And then she came up with this technique 30 years ago, which has been used ever since. And now there are variations on this technique with development. But there are bamboo buildings in existence 50 years. And as long as they are treated properly and well, then it will last. But again, there's a lot of work being done. I didn't show any of that. It's not research we do personally as a practice, our interests are in other areas. But there are, again, I would say in the 10 or 12 years we've been working on it, it's exploded the amount of work that's being done investigating the glues you use, the treatments you used. So yes, there are treatments that can deal with these things and make them durable. So the engineered bamboo at the back end there, they are being designed for 50-year life. And Base Bahai and Arup, the engineers from the UK, they are building humanitarian housing in the Philippines now, which has a 50-year design life. So they are, meeting the standards, the requirements of the kind of general design life of buildings that we use elsewhere on the planet, really. So.
Okay, so do you mean only by soaking the bamboo we can make the durability is longer?
Only by what?
Soaking.
Soaking?
Soaking the
It
bamboo.
has to be treated.
Oh,
You have to treat it. Otherwise it will be eaten very quickly.
Oh,
So it's very important. The timing and harvesting is critical. So the processes of growing, where you grow it, how you grow it, is very important. And how long it grows. So it grows fully in a year, matures over 3 or 4 years. But the maturation period is critical. If you harvest too early, it's too soft. Too late, and it's crystallized, and you can't use it. So, and there are things like, it's better if you harvest in the night time, for instance, right? Because the moon has an impact on the water in the bamboo. So things like this that you don't expect. But the experts around the world who know these things and have expertise. But the second you've harvested it, you have to treat it. And you have to treat it, and treat it properly, and it has to soak for quite a period of time. And borax treatment is it's not a bad treatment. It's not the greatest in the world, but it's not really heavily toxic or anything like that. So it's reasonable, but people are looking for different techniques. But yes, the second you've harvested bamboo, you have to treat it immediately.
so after we harvest it, we have to treat it immediately.
Yes.
And the maturity time of the bamboo is very important to use the bamboo correctly.
Critical.
Okay.
Drying time. So actually, harvesting, there's a certain drying period. You have to maintain a certain moisture content.
Oh.
Moisture content control is critical because above a certain moisture content, you get fungus. Below a certain moisture content, you get cracking because the comb dries very quickly, and it will crack badly. So remember, it's very important to understand all the time, you're working with nature. So it's not like working with a piece of steelwork or a piece of aluminium or a piece of concrete. You have to treat it as its nature.
Jadi pertanyaan Bu Dekan adalah bambu itu kan tidak awet ya. Mana yang kita tahu bahwa semua material alam itu tidak awet. Bagaimana caranya supaya meningkatkan ketahanannya, begitu ya Bu Dekan ya. Lalu berdasarkan jawaban dari Prof. Neil, memang harus ditreatment sebagaimana seharusnya kita mentreatment bahan-bahan alam. Dan ketika kita mau menggunakan bambu, ada hal penting yang harus kita perhatikan. Setelah kita panen, kita harus segera melakukan tindakan yang tepat supaya bambunya tidak rusak duluan sebelum digunakan. Selain itu, maturity atau umur panennya di tingkat yang tertentu itu harus benar-benar diperhatikan supaya kita tidak mendapatkan bahan yang tidak tepat. Demikian. Kemudian boleh silahkan tadi yang di belakang Bu Dekan.
First of all, thanks for the time for me to asking. First of all, I want to ask about.
Sorry, maybe you can.
I'm sorry. Let me introduce
yourself
myself first. My name is Vin Halianto, and I'm from.
Siapa?
Vin Halianto. You can call me Vin.
Vin.
Yes, I'm from architecture bachelor. And first of all, I want to ask to you, at what age is bamboo considered for the structures?
What age?
Yeah.
So, as I was explaining, it takes around 12 months to grow to its full size, something like that. Maybe slightly more, but then it needs to mature 3 or 4 years.
So it's runs 3 or 4 years.
Yes, but it's a little more complicated. If you begin growing bamboo from scratch, if you go home today, plant seeds of bamboo, it will take 5 to 6 years for it to grow, but you cannot use that bamboo structurally. It needs to go through a couple of cycles. And when you harvest it, you cannot harvest. The bamboo wants to be harvested, but not all of it. It's only a part. And you have to go through a number of cycles, so it's probably 7, 8, 9, 10 years before you can use the bamboo. I don't know why that is. That's a kind of, it's nature again. You know what nature does. But so when you grow clumps of bamboo, after 4 or 5 years, you cut 10%, let it regrow, and then you cut another 10% and allow that to happen. And eventually, after 7, 8, 9, 10 years, when you've had 3 or 4 cycles of the growth, then it's ready to begin using. But you never cut more than 10 to 20% or something. Because otherwise, bamboo regrows. It's a grass, so it regrows every time. This is one of the most wonderful things about it. Unlike a tree doesn't regrow when you cut a tree. It's dead, right? Not always, though, is it? I have a tree. I go for a walk every day, and I have a tree, these elder trees, and there's one tree which is cut like this, and the younger trees keep it alive. So this is a beautiful thing. Trees do that. They communicate, and they help each other, right? You know the book, The Hidden Life of Trees? You know this book? It's like the greatest book I ever read about trees. The Hidden Life of Trees. Yes, I recommend you all read it. For engineers who are studying trees, just buy that book, The Hidden Life of Trees, and architects. You will understand so much more about how trees work and why they are like they are. They communicate, right? They feed each other, they take care of each other. When they grow in forests, they grow in a particular way, so they're taking care of one another. They communicate, which is what the most amazing thing about it is, which is why I walk every day.
Okay. And for the second question is about when we were in bamboo forest, how can we identify the bamboo age itself? Because we don't know how
Which
to...
species you mean, or when it's ready to be harvested?
When it's species. So
Okay.
we
The
in the bamboo.
species. Mengidentifikasikan bambu.
Yeah. How to identify the age of the bamboo itself?
How to identify the species of the bamboo?
I'm right. So I told you I've been working with it for 12 years, and I would say I'm a novice. I know this much. And I do not know the answer to that question. But I know someone who does, a man called Jörg Stamm, who, if you're interested, he's a German, but he lives in Colombia. He's the most knowledgeable man about bamboo. He can recognize a bamboo species by looking. Me, I have to compare it with something else. And I think for now, until you get to know it better, you will have to do the same. But eventually, maybe you will recognize them immediately. But also, with harvesting, he walks to a bamboo and goes, and he knows if it's ready or not. This is 40 years worth of work, 30, 40 years worth of understanding. Takes him, he now can tap a bamboo, he can tell if it's ready to harvest. It's nature. You have to think about it very differently. John Hardy, when he grows bamboo now, he puts a ring around it with beads on it to show the moment at which it started growing. And that thing, so they can see what bamboos have grown when over what period. So there is a way of kind of measuring it, relatively speaking, but not like somebody like Jörg Stamm. That's the thing about it. You're working with nature, so you have to kind of understand nature. But if you're doing it, just keep going. Honest? Is that what you're interested in doing? Yeah, keep doing it.
And also for the projects with many curves or bends, that's your projects.
Sorry?
Your project is, when I see it, there's many curves or bends edges with the bamboo. And how do you prepare it for the bamboo? Is it, do you train the shape or the bamboo itself? And how long it will take? And how long does the process usually takes for the entirely for your construction?
To train the bamboo?
Yeah.
We don't do that.
Oh, you don't?
I've never done that. The pictures I showed you were somebody else. I've never been involved in training
Oh,
bamboo.
yeah.
We either elastically bend bamboo or we heat bend now. We're beginning to heat bend, but that's a kind of new thing for us because we've only really understood the process recently. So, but I think there's some, I recommend if you want to know more about bamboo, there's a book called The Gift of the Gods. It's the best book about bamboo that I know. I was given that years ago and I refer to it every week. Gift of the Gods. Can't remember the name of the writer. And then I think if you need to know more, we are developing a kind of website where if you have particular queries about bamboo, you can talk to people who know specific questions. I told you, 12 years and I know this much. I mean, I know a little in there somewhere. I know a lot about a very little bit, but not so much. But the one thing about the bamboo world is it is a beautiful world, right? Everybody helps everybody. It's something different about it, and I'm sure it's nature. I'm sure it's to do with the fact that it's nature. Everybody helps everybody else. So out there are lots of people who can answer every single question you need to ask or want to ask. I can't tell you the answer, but I can point you at somebody who can help you, and I'm willing to do that. You know, so anybody, if you have specific questions and want answers, I would be very happy. We, as I said, are developing this thing, which is like a library of people. So you can get in touch with the people you want to get in touch with, right?
Okay.
Thanks for the answer.
Okay,
No,
because we have limited time.
So Prof. Neil here in Forestry Faculty, we have also some books related to bamboo, bamboo identification. And also in Indonesia, we have one expert to identify the bamboo. Her name is Ibu Elizabeth Wijaya. And she is also founder of the Bamboo Indonesia Foundation, Yayasan Bambu Indonesia. So I think we should make a collaboration, and it's will be very interesting if we can make a collaboration on the constructing a website during the bamboo in Indonesia, which suitable for the construction and for others utilization. Yeah,
Right.
because bamboo. Have you ever eat a clump of bamboo?
No.
This very delicious one. We
No,
call it
no,
here.
no, I haven't.
We call it here rebung. Local name is rebung. Rebung is a young bamboo. Young bamboo is a culm of the bamboo, and we make as a vegetable here in
Okay.
Pontianak.
Are we having it for lunch?
Yeah, yeah. We will looking for that for this lunch.
Okay, good.
Yeah,
Excellent.
yeah. So you can taste the young bamboo.
Okay, beautiful. Thank you.
Okay. Yeah.
And about the connection, so we have a number of different universities who we're wanting to connect to.
Yeah.
Some have agreed already, but then we should have that conversation because it means we can connect to them, you can connect to them now.
Yes.
And
okay.
there are a bunch of universities who are very, very interested, and we just need to kind of complete the work and launch it. Because I think then there is a repository of information. The man I told you, Jorg Stam, who is the most knowledgeable man about bamboo, a few years ago he gave me a stick with his life on it. Right, this guy? It's got stuff in there you wouldn't believe. And we want to put it in this library and just say everybody can access it. Nobody, it's all free.
Yes.
You don't have to pay.
Yeah.
No, it belongs to everybody. It doesn't belong, we don't own it. It's not ours, it's not mine. You all gave me his life on a stick, so
Yeah.
it's not mine to sell.
Okay. Yes. Okay.
And so we
great.
would be very happy to talk to you about if we can do that.
Yeah.
You can add and we can do that as well.
Okay. Yeah. Thank you, Prof. Niels.
Thank you very much indeed.
Thank you for
Thank you.
Finn, for your question, but we have limited time. Maybe I will give last one question if there is a question from students. Okay, the last one, yeah? Only one question, please.
Okay, first of all, thank you for the opportunity. My name is Febrianus Juan from Civil Engineering.
Sorry, what's your name?
Febrianus Juan.
Febri, okay.
So, my question is, when you create a structure from bamboo, how do you integrate it with concrete or steel? And what are the challenges in doing so?
What was your name again?
Febri.
Huh?
Febri. Febri.
February?
Just call him man.
February?
Yes.
February?
Yes.
Okay. When you work out what the answer to that question is, you come and tell me and we'll employ you. Okay, you understand? Because I don't know the answer. But if you work it out, you can come and work with us. Does that make sense?
Pardon me, what's your answer?
I said, I don't know the answer, but if he gets it, he can come and work with us.
Please come to him and work with...
No, it wasn't nothing. Wait, he has to get the answer first.
So
when he has the answer.
he asked if you, when you do when you create a building.
When you create a structure from bamboo, how you integrate it with concrete or steel?
Yeah, that's what I'm saying. I don't know. But when you know, when you have the answer to the question, get in touch with me and we will employ
Karena
you.
beliau kan sepenuhnya
Because then you will have
bambu.
solved the problem.
Okay.
Jadi
It's a big
tidak
problem.
menghubungkannya.
It's difficult. I don't know the answer to it. It's a kind of negotiation. But you saw we did a building in the Philippines combining steel with bamboo. You saw that in the images, right? The building we did in the Philippines. This is a combination of steel and bamboo. So it is something that needs to be thought very carefully. But it's happening, but slowly. Understanding how to combine bamboo with other materials.
So you only use bamboo, not combine it with steel.
No, we do. We've done combined with steel, but not yet with The problem is in kind of the Western industrialized construction industry, bamboo doesn't really go together with it. You know, bamboo in its natural form.
Tidak terlalu baik jika digabungkan, gitu ya. Jadi beliau bilang beliau tidak tahu, tidak bisa memberikan jawabannya, karena memang beliau bekerja di bambu dan mungkin belum pernah menggabungkan material-material yang kamu sebutkan tadi, gitu ya. Bahkan beliau bilang kalau kamu tahu silahkan beliau juga. Gitu. Okay, maybe from
Sorry, my colleague and friend just reminded me. If there's a course in Bali called Bamboo U, which is a 10-day course, which is probably one of the best courses you can get if you want to understand in depth quickly about how bamboo, what it does and how it works. It's called Bamboo, B-A-M-B-O-O-U, and it's run in Bali.
Yeah,
and I talk at that course, and I'll be there in July, but they're every 3 or 4 months.
So actually, I ever stayed in Bali in 3 months, and I knew about Bamboo U Bali. There is Instagram, jadi ada Instagramnya Bamboo U Bali. So in that Bamboo U Bali, they give education to people to come to learn about bamboo, right?
That's right.
And to learn about the structure of bamboo. At that time, I wanted to learn, but yeah, because of some reason, I delayed it.
No, but they talk about the technical, the stuff I was showing you, but also making it.
Yeah,
how to work with bamboo,
yeah.
how you grow it. So if you want a general knowledge, I mean, of course you can read about it, but there you get an experience with it, which is, I think.
Jadi kalau ada rezeki, boleh main-main ke Bali. Datang ke Bamboo U Bali, nanti di situ kalian bisa belajar tentang bambu, sekaligus langsung praktek bagaimana cara buat struktur dari bambu. Ini saya promosi nih jadinya ya. Oke.
So I'm going to invite you. You want to go, right?
Huh?
You would like to go?
At that time.
No, well, any time.
At that time.
Okay, well, we should talk about that.
2 years ago.
We should talk about it.
Yeah, okay. So, because our time is very limited, Prof. Neil, maybe we will close this session. And thank you very much for all of the participants. And I will close this session. Bamboo revolution refers to innovative transformation of bamboo, a key of non-timber forest product NTFP, into advanced materials for structural and architectural uses. This movement promotes sustainable alternative sustainable material, leveraging bamboo's rapid growth and its good compression and tension properties. It supports carbon credits and also eco-friendly construction, both rural economies in regions like West Kalimantan, and aligns with SDGs for sustainable forestry and poverty reduction. And that's all from Prof. Neil. Maybe we can give applause once again for Prof. Neil.
Thank you.
And I will give back to our Master of Ceremony, Miss Chut Febriana.
Thank you to Professor Neil Thomas for the insightful presentation delivered today, and to Ms. Sari for serving as the moderator. Next, giving souvenirs from the Faculty of Forestry, Tanjung Pura University, to Professor Neil Thomas and Mrs. Faradiba are invited to come forward. Ladies and gentlemen, that concludes today's session of the Ramin Series 54. On behalf of the committee, please accept our sincere apologies for any shortcomings during today's event. Thank you for your attention and participation. See you again and have a wonderful day. Wassalamualaikum warahmatullahi wabarakatuh.